Yeah, it's your boy Chili here. Welcome back to C++ Game Engine Infrastructure. Today we're continuing on with our logging utility, and I want to talk a little bit about the severity levels because I kind of just added these in, but I didn't really spend any time talking about them. I just glossed over them. And often when I'm faced with using a log library, I have difficulty deciding, which level to use when I'm going to do a logging. Yes. And it's even harder to decide these levels when you're making the library. How many levels should I put in here? Too many levels and it becomes very difficult to decide between them. Too few, and that has its own problems. So let's discuss the ones that I've added here and my rules of thumb on how to decide which one to use so we can, maybe avoid some analysis paralysis in the future. So we start with fatal. So fatal means an error happened, program is not working as it should work, and furthermore, we cannot continue. We should not continue. We are going to terminate immediately. We're going to print a stack trace, and that's it. It's over. We're not letting the program continue. Now, error is also something didn't work as expected, but we're not going to terminate the program immediately. So the program has probably entered an invalid state. Its behavior might be compromised, but we'll often pair an error with a throw and try to let a higher level recover from this. Now, if the exception bubbles up to the very top, we will crash just like fatal, but an error is a thing that maybe it's possible we could recover from this. So we might even log the error, but do nothing and just pray. We just pray that, the program continues to run. And I think in most cases, we do want to also do a stack trace with an error, but it's a little debatable because what if we are in a release build and we're in a situation where we just pray that the program can still run properly. But if it actually can run in this state and do something useful, but it's constantly hitting this error and printing a stack trace, it's going to slow it down like crazy. So there's some debate on whether we do a stack trace on an error. Maybe on some we do, maybe on some we don't. But I think in general, we do want to do a stack trace. We're usually going to throw. And that's what that is. Now, a warning is a potentially undesirable state, but I think in this case, it typically does not mean that the behavior is compromised, so to speak. Like, imagine, here's one example. Imagine we have to load a config file. Now, the first time you run the program, the config file doesn't exist. The program has to generate it. So the very first time you run it, it will fail to load the file. But that's actually expected if it's the first time. So in that case, you might print a warning saying, we failed to load the configuration file. Now, that might mean that it's just because it's the first time you run, and that's fine. Or it might mean that it's just having trouble finding a file that actually exists and it should be able to load. You're not sure, maybe you print a warning. It's possible this could be okay, but maybe it's something to look into. Another thing that might be a warning is imagine user has some kind of bad settings in their environment. I don't know, something with their graphic settings, and that causes your program to use a non-optimal execution path. So it's doing something, it's still working properly, it's still producing the correct output, but it's possible that the user could change a setting to make it more efficient. That could also be a warning. So for warnings, obviously we do not terminate. Also, we do not print a stack trace. Now, info is a tricky one. I'm not sure how many of these I want to put in the program if I'm being completely honest. It's not a cause for concern. Info is printed even when the program is running perfectly fine, optimally, and you're tracking the flow, the large big picture flow of the program. You're logging major milestones of running the program, finishing an initialization phase, or you've made a connection, or you've loaded a scene or something. So you don't want these in a hot loop because you don't want to be logging this just general information, spamming the log and killing your performance. But I mean, you could put it in there just for someone who's reading a log to understand the flow of the program if they're trying to diagnose an issue. So to be honest, I don't know how many of these I'm going to use, but that's the general guidance of when you would want to use it. Now, last two here, this trace, first of all, I'm going to rename this to verbose. So give me a second. All right, just rename this in here, in here, in here. Okay, so we're back. All right, so debug and verbose. So these ones are a little special in that they can be compiled out of the program. So if you're running, for example, a release build, these will completely disappear from the source code. They will incur zero performance overhead. I do have a little difficulty deciding when to use them, and I don't use them very often. But the general idea, I think, should be you would use a debug. You're sort of like tracking some intermediate results of a large process just to see every step along the process, do things match up with your expectation. So these are typically not errors, although you could, have sanity checks in there, maybe as a kind of like assertions, and those would be debug level. But I think generally debug is more about just tracing intermediate steps of a process. And that's actually the same as verbose. Verbose is also tracing intermediate steps of a process, but verbose would be more fine-grained. So verbose would be like almost like every single different calculation you do in this process, you would output the intermediate result. So verbose would generate a huge amount of log spam, and it would probably slow your program down by a crazy amount. So my idea is that by default, debug will be enabled in debug builds, but by default, verbose will be disabled, and you have to manually enable verbose mode in order to compile in those verbose logging statements and to generate that information. Another feature that I want to be able to add, and I know that other logging utilities like Google Log has this ability, is in verbose, you can actually fine-tune what part of the code you want to compile verbose on. So, for example, you can say, I want to add in the verbose logging into my compilation, but only for the file module or only for whatever module, and that is based on the CPP file name. So for every translation unit, you can turn it on or off. And that's very useful because verbose will generate an enormous amount of logging. And if you did that for every component in the program, that could just make a log that's so crazy to try to, figure out afterwards. And also it'll kill the performance. So the ability to enable verbose on a per module basis is something that I would like to add to this at some point. But generally, these two, I don't think I will be, when I'm coding up a new component, I doubt I will add these in. The timing that I add these in is when I'm trying to debug an issue. I'm trying to figure out why is this not working? I'm fixing a bug, and so I start logging stuff as part of one of my bug crushing strategies. So normally what I would do without this facility is I would just add the logging lines in and then run the program and do my troubleshooting until I fixed it, and then before I commit, remove all the logging lines. Now here's the problem with that, because I've been down this path many times. You add in all the logging lines, you find your issue, you remove them all, you go forward, and then you find, oh, there's another issue, and then I got to go back in and start adding in these log statements. So instead of that, what you do is you add them in as verbose or debug level, and then when you're done fixing the problem, you just leave them in there because you know that they're going to get built out in release, or if it's verbose, they'll be built out almost always. So you leave them in there, but you just leave them in a dormant state. And then if you ever need to debug that code again, you have all those traces in there that you can activate and call upon when needed. So yeah, that's the general idea here with the log levels. These are just rules of thumb. They might not apply to all situations. I'm going to bend these rules if I have a rationale for doing so. And I mean, there's a lot of issues that I still don't really have the answer for. We'll have to find our way through as we go along. Like, when do I make a log debug versus verbose? Because debug sticks around and generally outputs during development because you're running in debug mode and it'll be turned on by default in that mode. So how many of these traces do I want to leave in just all the time versus do I want to enable just some of the time? Or also, do I want to add in debug traces while I'm initially building the component, or only after I have to start troubleshooting it? And other systems, they have actually like multiple verbose levels. So you can have like verbose 1, 0, 2, 3, 4. And I mean, so many options that just seems to me like that's just more analysis paralysis. So I don't know, but maybe there's some merit in having 2 verbose levels. So verbose and like super verbose. So maybe verbose would be just normally logging every step, but super verbose is reserved for stuff inside of your hottest loops or something like that. So yeah, I don't have all the answers, but this is generally what we're going to roll with to begin. Now, here's the thing about these log levels. Generally, you can enable them at runtime as well. So, at compile time, you can compile out these two. These ones will always be compiled in, but you can decide whether or not to log at a level. So they go in order. So the simplest order is log nothing, right? Then you could just log only fatal errors. Then you could log fatal and normal errors. And then the next level is log warnings, errors, and fatal, info, warning, error, fatal, so on and so forth. So what I want to do in this video here for a little coding is implement the ability at runtime to change what level you log at. And the way that we're going to do that is we're going to use, this is one of the places where policy can come in handy. So we're going to use policy. So, according to this diagram here, a channel has an array of policies, and we can apply those policies to an entry before they are submitted to a driver. Now, I could make an interface for the policy, and I guess I will. So we'll do class I policy, and then we'll want the ability to attach a policy. So attach policy. Do we want policies to be shared? I don't think so. I don't think we need that, but something to think about, I guess. And now for our default channel, we will have a vector, policy pointers. Visual Studio added this in there. Sneaky little monkey. Get rid of that. Attach policy, override. All right, so now I think we're going to want a policy interface. Now, policy can transform, filter an entry. That's right, it returns a bool. Bool is the flag that it returns to determine whether or not to use the entry or to discard it. So if it returns false, that means discard the entry. And we take in the entry by a non-const reference, so you're able to mutate that entry. Open question is whether or not you would want to make the function const, but I will allow the policy to also maintain some internal state that can be mutated whenever it transforms an entry. So maybe that'll be useful at some point. So yeah, there is the interface for a policy. Now let's make a log level policy. All right, so here we call it the severity level policy, implementing the I policy interface, and it is one piece of data, which is the level that we log at. So I got to decide the logic for this. We'll figure that out. Let's go in here. So the idea here, transform filter. So what this one should do is it should return false if we want to discard the entry. So what I think I want to do perhaps is reorder these so that fatal is at the top maybe. And then at the very top here, we're going to do none. We're going to add a level none. And so that will be 0, 1, 2, 3, 4. Okay, and this will make it the logic easier. We convert the enumerations then to an integer value. So we return we don't have, so we need the definition of entry, and then we return e.level is less than or equal to level, which is the level that this policy is targeting. So if level is none, nothing will be less than or equal to 0 because you can't log a none level. So that should work fine. And then in here, very simple, we just do level underscore that like that. There. So this is very simple implementation of a policy. It doesn't mutate or anything. It just checks and discards based on the level. So now in channel, we can just implement attach policy, which doesn't even need the definition of policy, right? And we just do policy pointers dot pushback std move p policy, and there, this goes in here, and that should be good, right? The problem here now is that this should be an I policy. There you go. Perfect. All right, so now we should be able to attach policies. Now, here's the thing. We're not using those policies yet, are we? So, what do we do when we want to use a policy? Well, first of all, we go for. So we'll loop through all the policies in our policy stack, and if any of them return false, now we do need the definition of policy in here. Yes, so now if any of these transform filter calls returns false, we should just return without submitting to any drivers. So we run all the filters, and if any of them return false, we skip this step. Yeah, so that should be that. Let me do a quick build. All right, so mock channel doesn't like it, of course, because it's got, you know, another function that it has not implemented. So if we go into here, we can implement pure virtual functions. Yeah, so that will be this one. All right, so here's an interesting error that we come across. Use of undefined type chill log I policy. You might be wondering where is this being used? It's not being used anywhere. And the fact of the matter is, if you put the default destructor, you have your default destructor in your header, it's going to try to generate the destructor, and then it's going to need to know the destructor for any of these types here. That only applies for unique pointer though. Shared pointer doesn't have that issue, and that's the way it has to do with the way that these two differ in the way they store their deleter function. So to get around this problem, all you have to do, it's not that difficult. You just declare your destructor. You don't even have to do override or anything. And then you define it in the CPP file. Let's create the definition in here, and we'll just make it an empty one. And this should allow it to compile. So there's a little trick. If you're forward declaration pilled like I am, that's how you get around that issue. Well, let's see. Now we're still getting an error, and that error actually comes from logentry.cpp, which is one of our test files. And the reason why is because in here we're implementing a mock channel that has to implement the attach policy, which means there's a local I policy argument, and it needs to be destructed. So in here, in our test here, we do need to know the definition of core source log policy. Now, if we do this, it should build. And indeed it does. All right, so now finally we can test our policy, and we'll test it inside of the log channel testing site here. So how do we test our policy in this context? Well, we'll add another test channel policy filtering. So we will just make a single driver for this one. We don't need to do multiple drivers. And we will do auto p policy is equal to std. Well, I guess we should include # include core source log severity level policy. So we'll do std make unique log severity level policy, and the level will be log level, and let's go for the level info. All right, so then we'll do channel.attach policy std move p policy. There you go. I mean, we could just do it like this, right? So we're not going to mock in the policy. We're going to be testing the policy in the same file that we test the channel. You know, it's probably not best practices, but I'm not too worried about it. And now we're going to log a debug level. And we should see that the entry stored in our driver shouldn't change. So we should see the same entry. And that is if the policy is working correctly. Test policy filtering. Yeah, we got to change the name of the test method. So let's run the forwarding test. And it works. So the info log made it through, but the debug log was quashed. All right, so final little test here. We are going to log at 3 levels, and we're going to attach to our channel. Let me see here. We're going to attach a policy. That is going to be severity level error. So we should see the fatal and the error get through, but the warning will be quashed. So let's build that. And if we run it, we can see fatal, and we can see our fatal here. We can see our error here, but the warning is nowhere to be found. So that's good. So that is that little feature added. And with that, I think we've basically covered everything in my diagram here. So that doesn't mean we're completely done, but we are getting pretty close to at least what I want to get down before we move on to different topics. But yeah, it's a very important feature to be able to set at runtime the logging level. In a release build, probably for performance sake, you would only want to log fatal or fatal and warning, but you might want to give the user the option by a command line switch to enable, info, warning, maybe even debug. And by enabling those, if they run into a bug, they can generate a log, send that to you, and then maybe that'll give you some hints on how you can reproduce it on your end. Another idea is that, we're attaching policies to our channel. We could also attach similar policies to our each driver and then have per driver processing. Now, one limitation of this system is that in order to have these log entries filtered, you must first build a complete log entry and then submit it to a channel. But the building of the log entry in some situations, that can actually be quite expensive. And we would like to be able to avoid even building the log entry. So we would have to rework the system so that you can check log level before passing it to a channel and processing with policies. So in the end, we might not use policies for our log level filtering, but it is certainly the easiest and a very clean way of enabling that. Last thing, we have the ability to attach, for example, to a channel, we can attach drivers, we can attach policies. We have no way of removing drivers or policies or any other kind of editing functionality. So depending on how we go forward, we might want that feature in the future, and we can add it in then. But for right now, we'll just set things up by attaching drivers and policies once and then leaving them like that. Same idea with the severity level. We only set it when we're constructing the policy. We can't change it afterwards, but we might want the ability to change it later on. But that's going to about do it for this video. Hope you enjoyed it. If you did, please click the like button, helps a lot. And I will see you soon with some more C++ game engine infrastructure.